Will be directed to your final, yeah?
Is the chapter 3 test the hardest?
Chapter 3 is the first test we haven't split up. If you remember, we did chapter 1 in 2 tests, we did chapter 2 in 2 tests, chapter 3 we're doing all at once. So, I don't know how you feel about that, that's just how it is. Okay, so problem number 11. We have got it all set up, no one has a question about this. So I'm going to do what I did before. I'm going to type in my numerator. So 1 minus parentheses, 1 plus 0.0875 divided by 12, close parentheses, raised to the negative 360. Okay? So somebody tell me what you got when you typed in just the numerator.
0.92.
Perfect. 0.926. Yep, you got it. Okay? Now we're just leaving it. We're not doing anything with it. Now, guess what I'm going to do next? I'm going to hit divided by parentheses 0.0875 divided by 12. Now, do you have 127? Okay. Now, this right here is the 127 that's on your calculator. You're solving for R. So we're going to take 86,000 and divide it by second answer. And your month, or this person's monthly payments are $676.56.
Where do we do that second answer?
You press second.
Okay.
Answer.
Where's the answer?
If you were looking at me, I am pointing to it.
Oh, there it is. Got it.
All right, if you're still struggling, let's try another one. Here we go. Joel invests this into a retirement account with 9% interest rate. Whoa, stop right here. What formula am I using for number 12?
FP. F.
Stop.
Oh, PV.
No.
Stop.
Either.
They're using the compound.
I'm not exactly.
Compound.
Remember, PV and FV are for what? Making payments. Is Joel making payments?
Compound.
No. No. So we're going to use our regular compound interest formula. So again, you do not need to memorize this, but you need to know how to use it, and you need to recognize that it's the formula for this problem. Okay? So what am I doing? She invests $8,000, 9% interest rate, compounded monthly, and she wants to basically double her money. She wants to end up with 16,000. All right? Does that make sense to you?
Yeah.
Okay? So, uh-oh. See where my variable is?
Yeah.
That means I will eventually need logarithms. Not yet, because the first thing I have to do is divide by 8,000. So let's divide by 8,000. Okay? Now, when I am solving for an exponent, I need to I need to use logarithms. So I've already divided. So now I'm going to use logarithms. So I'm going to log both sides. And this is magically and wonderfully going to come out front. Remember, that's one of your properties of logarithms. Now, my job is to solve for t. So what am I going to need to do to get t by itself? What am I going to do with this? Divide by 12? So I'm gonna take log 2
1/6.
and divide it by 12.
Oh, wait.
And that's gonna leave me with, T log this, right? Now what's the next thing I'm gonna need to do? I'm not typing this in because
Divide by
your answer is going to get thrown off with every rounding you do. So I'm gonna wait until the end to type it in. What else do I need to do if my job is to get T by itself? I have to divide by log 1 plus 0.09 divided by 12. Now, I know it looks messy, but I want everybody to look at it and make sure it processed. We took the logarithm of both sides and pulled the power out in front. This is what I want. So I'm gonna have to take log 2 and divide it by 12, and then divide it by that, and my calculator will do that. So log 2, close parentheses, divided by 12, and then divided by log 1 plus 0.09 divided by 12. And I get an answer with 0 round off, 7.730 years. How long will it take her to double her money? A little less than 8 years.
Yeah.
Okay, so log 2 divided by 12, and then whatever you get, divide that by this. Okay? All right. Number 13, step 1, figure out which formula you're going to use. I heard Elijah say PV. What do you think? PV? Why? Because I'm paying off a present loan, right? So here we go. First, I'm going to write down my formula. All right, there's my PV. All right, so here we go.
Don't know the difference.
What is Erica's monthly payment? So aren't I looking for R? What's my interest rate? 0.1025, yeah, 0.1025. Now, how frequently is she making the payments?
Monthly.
So, not in, but under there I have to put a 12.
And then 36.
And she's doing this in 3 years, so that's negative 36. Remember, it is negative in this formula. And I'm gonna divide by 0.1025 divided by 12. And what's this gonna be equal to?
4,500.
That's the present value of the loan. That's right. How much does she owe? $4,500. Okay, we did one like this a minute ago. My strategy is gonna be, I'm gonna have you do it by yourself, but my strategy is gonna be, I'm gonna type in my numerator. I'm gonna get a value, then I'm gonna divide that by this. Get a value. Then I'm gonna take 4,500 divided by second answer. And that should be the amount of her payment. So let's see if we can all do that. Oh, they're not as bad as I thought. Did you get 145.73?
Yep.
Okay. All right, number 14. listen for number 14.
The opposite of the compound.
On number 12. We got
One number.
no.
Okay, guys, let's this. It's really easy to decide. All right, so let's all listen. Let's listen. PV and FV are used when you are making payments.
Yes.
The only time you're going to use PV and FV is when you're making payments.
It says payment.
So, number 14 will be either PV or FV because I am making payments. All right? Got it? Now, which is it?
PV.
It's
Or
FV. Why is it
My bad, my bad.
FV?
You're not paying, you're putting for the
Because
future.
she is
Investing.
investing in the future. FV, F, future.
So would PV be when you have the grand total payment?
When you're paying off a loan. Okay? All right, so here we go. I need my FV formula, so I'll write that down. All right, and now let's plug stuff in. All right. What do I do with the 50?
50 doesn't come up, Mr. Reed.
That's her payment value. Remember, R in this formula is the payment amount. Interest rate is 0.0726. How often is she doing this? Month? Let's see, she's doing it a month for 25 years. So what's that?
300.
300? 12 times 25? And that's positive. How does that look? Does that look okay to everybody? Folks? All right, let's type it in.
This is 40.
Hmm?
For FV, would the denominator always be 12?
No. Depends how many payments you're making a year.
Is it for monthly or quarterly for the annually, which is just one, right? Yeah, annually is just one, monthly or quarterly.
I got $42,211.46.
Got 41,260.
Uh-oh.
Oh,
Something like that. Something like
Wait,
Could be
hold on,
me.
let me do it again.
Could
I
be.
got 42.
You got that?
that. Oh, wait. Oh, I see where I got it wrong at.
Yeah.
I typed it in.
It's right, it's right.
Yep.
Alright, thank you.
Oh, never mind.
All right, one more.
Oh.
What do you think for number 15?
Same one.
Same one? Same formula? And I'm looking for that value. I'm gonna invest $50 a month. Interest, whoa.
Wait, what?
0.155.
That's a pretty.
That is a pretty significant interest rate. What's my N? 20 years, 240? Remember, N is how many payments you're making all together. So he's making 12 a year for 20 years. $1,367.73. Okay. A long time ago, I handed out a review sheet packet. It was back when we were practicing exponents because I put the practice quiz on the back of the packet. So it's 3 stapled sheets. I don't know what side you count as the front. Page 1 looks like this. Yes, you did. Because we did the quiz, the exponent problem. Honey, if I have any, they're in that black thing back there. You are looking at totally the wrong thing. It's in that black bin if I have it. I don't know if I do or not.
No, I just know we need this.
Okay.
Oh, was it, oh, that wasn't here.
Now it is time for Mrs. Ford's lecture on credit cards. Okay? Now, I use a credit card. I don't know that you can survive very well in the world without a credit card. All right? I use one. But guess what I do every month?
Pay off your
Pay it off.
Pay it off.
All right? So I'd like you to look at review sheet number 1, the very front, the first side there. And let's take a look at problem 8E. We're going to look at problem 8E. Okay? 8E. Current credit card balance on an account is this. The interest rate is this. If the student is to pay the card off in 6 years using monthly payments, what will be the amount of each payment? All right? So this kid has gone on some kind of a spending spree, but he's gonna pay it off in 6 years. All right, what formula? He's gonna make monthly payments, PV. So I need my, we'll still need our notes for the formulas. I don't think I put them on there. So PV. You guys, this is gonna amaze you, so please, please, please pay attention. All right, he knows that, he has a loan, he's gonna make payments on it, PD. The present value of the loan is 1, 2, 3, 4, 5. We don't know what the payments will be, we're gonna figure that out. But we know the interest rate is 0.1899, which by the way is low compared to today's interest rates on credit cards.
Mine's 30.
Tell me, am I right?
30, 72, negative 72.
We're gonna do it for 6 years, once a month. So make sure you're good with the numbers and where they are. Is everybody good with that? Okay, so now we know we're gonna be dividing, or we're gonna be solving for R, so we're gonna have to figure out what this is and then divide that by it. So we've done ones like that, so let's go ahead, see what you can come up with. Try to do it, Colin? No. come on. I got 288, I don't know, I couldn't have done that
No, I
wrong.
got that.
Is that right? Okay. So this kid's gonna be paying $288.51 every month for the next 6 years. Now, keep in mind, guys, that is on his existing balance. So he's not charging anymore. We are gonna spend 6 years paying off what he's already charged. We're not adding to that. Now, let's see how much he will have paid by the time he's done. So 288.51 times 72. So he will have paid $20,772.72 on an initial investment or expenditure of 12,000. Look at that, almost double, not quite.
Today it would be an extra 12%.
Yeah, a lot. So, credit cards are wonderful things.
But
Never
Gotta pay 'em
use
off.
them unless you have the money to pay for it right now. Right now. So yesterday, when I go to Hallmark and I buy the ornaments for my grandchildren, and it's $130 whatever dollars, I slid my credit card, but I know that in my checking account, I have money to cover that. So at the end of the month, I'm gonna pay it off. Every time.
that makes
I
sense.
don't
Is it better to use your debit if you have a Chpt card?
have a debit card. I don't like debit cards.
Why don't you like this?
So your credit cards, you get points.
Credit cards have protections that debit cards don't.
And you also get like,
So if somebody steals my credit card and runs up a back, I don't get charged for it. But if they take my debit card, I have to. Yeah, I don't use debit cards, I don't like them. Because I'm talking to them for 6 years. All right, oh, I guess the formulas are down there. Okay. While we're in part A, while we are in part A, we did E, let's do one more from part A. Who can see a problem that you want to do in part 8? I mean, part 8. A? How long will it take to triple an investment if the interest rate is 3.2% compounded annually?
Regular compound interest.
So I am gonna use my regular compound interest.
We get that on the test.
Yes, you don't have to memorize any formulas.
I said yes.
For these, we have 4. You don't have to memorize. Alright. How long will it take to triple my investment if the interest rate is 0.032 compounded annually? Alright, I'm missing a whole bunch of stuff. What's N?
N is 3. Oh, it's 1.
N is 1. Why is it 1?
It's annually.
Compounded annually, that's once a year.
What?
If it were compounded quarterly, N would be 4.
4.
This is just for 1. What's my A and P?
The P is. We don't know.
Okay, wait, what do we know about A and P?
It gets triple. It's 3 P.
So whatever P is, make up a number. A will be 3 times it? And remember, we talked about this the other day. You're allowed to do that because the first step is going to be to divide by 10, and this is going to be 3. You see that, folks?
So can't you just put 3? Like, do you have to?
You absolutely can, and then that would be 1. Yeah. Since that was 1, this is 1. Now, how do I solve that? Look where your variable
You
is.
do a loopy loop.
No, I gotta take a
You do a loopy loop. And then you do.
sometimes I use ln,
There you go.
I I could here, it wouldn't help me at all, won't change anything, but you always can use ln, you always can use log. It never matters. If the problem has an e, ln's make it easier. Pull the exponent off. And divide. So log 3, don't do the closure parentheses, divided by log 1.032. Did you get 34.878 years?
We need a variable.
Anybody else get that? All right, so tomorrow we will start reviewing. We'll start on this sheet, we'll try to complete this sheet. But certainly, if you have other questions, and look at those.